All right, let's look at the formal method for doing these sorts of limits. Now, this example, before we do it with the formal method, let's just look at it. 3 over 5, this is going to give us 3/5 for our answer. But let's do this formally. Formally, what we would do is multiply the top and bottom by 1 over d. 1 over x to the d, where d is the degree of the denominator. In this case, the denominator has degree 1, so what I would do is multiply the top and bottom of this by 1 over x. All right. When I do that, the limit is still going to negative, x is still going to negative infinity. Now I've got to distribute this 1 over x times both of these things here. 3x times 1 over x plus 4 times 1 over x. Then downstairs 5x times 1 over x plus 7 times 1 over x. Okay, now if I multiply that out, 3x times 1 over x, those cancel and it just leaves me with just 3. And then I get plus 4 over x. Then down here I get 5 by itself. And then I get plus 7 times 1 over x, or 7 over x. Now I could go through if I wanted to and break this up into the limit of the top over the limit of the bottom, and then do the limit of each one of these things individually. But I'm going to use some notation here that's pretty common. What I'm going to do is I'm going to say as x goes to infinity, 4 over x goes to 0. And 7 over x also goes to 0. So what we're left with here is just 3 over 5. I could write the limit in again if I wanted to. But I guess I don't need to. That brings up a good question. When do you stop writing limit? Pretty much it's when you plug in the number. So that gives me 3 over 5. Let's do one more of these the formal way. For this example B, if I wanted to do it formally, I would multiply the top and bottom again by 1 over x. Now I'm going to distribute that across here. So the 1 over x gets multiplied by each of these guys. But instead of rewriting it all, I'm just going to go through and divide it out. 2x squared times 1 over x is 2x plus 6 minus 9 over x. And downstairs we get minus 5 plus 4 over x. So now, if you look at what happens here, when x goes to infinity, this term goes to 0, and so does this term. Well, what about the 2x? Well, when x goes to infinity, 2x goes to infinity. So what I'm left with here is, you think of this as infinity plus 6 over negative 5. Writing infinity in like that is a little bit it's a little bit informal, but it gets the point across and it's worth doing, I think. So you've got infinity plus 6 divided by negative 5. That's going to give us negative infinity. And if we wanted to check this by doing it the way we've been doing it, if you just look at these, you get 2 times infinity squared over negative 5 times infinity. Sure enough, you get negative infinity. Now, the reason I wanted to talk about the formal method is it works in other places where we have functions that aren't exactly rational functions. Notice up here it says this also works for functions that have a square root in it. So let's do one of those with the square root. All right, this looks nasty, but it's really not that bad. All I need to do is take this and multiply the top and bottom both by, in this case, 1 over x squared. Because remember, the thing we're multiplying by here is 1 over x to the degree of the bottom. So since this is x squared down here, we're going to multiply by 1 over x squared. All right. Now, here's the thing. When I multiply this through here, the bottom is going to become 1 over x squared times x squared plus x plus 1. We'll distribute that in a second. Up top, I'm going to write this like this. Let's see, 9x to the 4th plus 3x squared plus x plus 1. Now, I've got to move that x squared inside the radical. And what do you do when you move something inside the radical? You have to square it. So when this x squared goes inside, it's going to become 1 over x to the 4th. So inside my radical, I've got 1 over x to the 4th times 9x to the 4th plus 3x squared plus x plus 1. And downstairs, I've got 1 over x squared times x squared plus x plus 1. All right. When I multiply that out, okay, on top, I'm left with square root of 9 plus 3 over x squared plus 1 over x cubed plus 1 over x to the 4th. And on bottom, I'm left with, let's see, this is going to give me just 1, then plus 1 over x plus 1 over x squared. And now all of these things up here, except for the 9 and the 1, when x goes to infinity, all of these things are going to go to 0 because they're 1 divided by something growing large. So what I'm left with over here is the square root of 9 over 1, which of course is just 3. So that's my answer. And you might ask, is there a quicker way to do this? And the answer is yes. Let's take this and copy it. I'm going to come down here and redo that problem. Truth is, you can take this and look at it and say, well, the top, I've got 9x to the 4th. That's my main, that's my leading term. And on the bottom, I've got that, x squared. So the top, when you take the square root of 9x to the 4th, you get 3x squared. And so you're just left with 3. You might say, what about all this other stuff? The reason I'm able to ignore all this other stuff in here is because this is a limit. So the reason for that is as x goes to infinity, it's only the two biggest terms on the biggest term on top and the biggest one on bottom that are going to affect the answer. So I can do that, but it's because of the work that we did up here in when we did it the formal way. I'm probably going to ask you to do at least one problem formally, but for the most part, I'll be asking you to do these informally. Let's see, what's the next thing? There is no next thing. That's the end of this section. All right.